Okay. Well, some of you are rolling right down through it. Good job. Now, there's different ways, of course, to do every problem, but what you might consider doing is setting it equal to x, because I think if you do that, you will see that it can be loop-de-loop. So 4 to some power is 1/16? Negative 2. Yep. So 1 over is a clue that it has to be negative, and 4 to 16 is squaring, so negative 2. All right, you can do exactly the same thing with the next one if you want to. 11 to what power is 1? Well, the power has to be 0. Now this one, think about what does a number, a coefficient out in front of that's an exponent. So this is the log base 3 of 81. And what does that equal? That equal,
81.
So that equals 4, 3 to the 4th is 81. Okay, you don't necessarily have to go through all this, but you gotta get 4. There's the answer. So here's a step-by-step way to get it. All right, so now we have the log base 7 of 1 over the cube root of 49 equal to something. So 7 to some power is going to be 1 over 49 to the 1/3. Remember, a cube root is a 1/3 power. So 7 to some power is 7 to the negative 2/3. Why is it negative? It's 1 over. And why is it 2/3 instead of 1/3? Because 49 is 7 squared. 7 squared. So the answer is negative 2/3. That's exactly right. Remember, if there's no base, it's automatically a 10. So we want to know what power do we have to raise 10 to get 1,000, and the answer is 3. This one you can do a couple of different ways, but if you think of it as ln e to the 1/3, which is what you need to pass the resource. Okay, so we know that ln and e, when they touch each other, do what? Cancel. So the answer to the problem is just going to be 1/3. Where did that 1/3 come from? Cube root. Remember, cube roots are 1/3, square roots are 1/2, and so on. Now be careful here. The ln and the e aren't touching each other because it's a 1 over e. So you might want to rewrite that as e to the negative 7th. Is that 1 over e to the 7th? And now they are touching, so the answer is negative 7. All right, now we are actually have an equation solved. What's the answer to A?
Square root 17.
Yeah, it's 17 to the 1/2, which is the square root of 17. Did you get your headphones back, those blue things?
Yeah.
All right, B. Be careful with B. The first thing we have to do is combine these,
Yep.
right?
X plus.
And when we combine them, they're gonna combine as a division.
You want to split equal one.
Well, that's part of the equation, I mean, that's there on the paper. So this is where I am so far. Now what am I gonna do? I put my logarithms together, which is what I need to do. Now I will. What now?
I can do
Yep, so 3 to the first equals x plus 2 over x. So 3x equals x plus 2. Looks like x equals 1. Anybody else get that? When you solved it? Alright. Alright, number 3. Consistent growth or decay? Decay because 0.73 is less than 1. What is the rate of growth or decay? No.
Oh,
0.2.
No.
0.27.
27%. You guys, the rate of growth or decay is how much different from 1 you are. So 1 minus 0.73 is 0.27. So that's a 27% rate of decay. Everybody got that? Okay, we can't miss these and things like that. But what's the initial value?
130.
130. All right, number 4, simplify.
3 over.
3 over x to the 4th. Only the x to the 4th goes to the bottom. Would you agree with me?
I agree.
Okay. And then b is kind of big. What do you want to do here?
This first is move it.
My own personal preference is I like to clean this up as much as possible. And then I'll take everything to the 2/3 power. You can take everything to the 2/3 power right now. The problem is that's gonna put some fractions in here. So I think I'll clean it up and see what happens. Jaden, I need your head up, sweetie. Okay? All right, so I'm gonna have 8 and 27.
And x is 9.
These are gonna come down. So I'm gonna have x to the 12, and I guess y to the 5th is all I got there. Now remember that everything in the parentheses is gonna go to that power. So we're gonna have 8 to the 2/3. We're gonna have y to the 10/3. We're gonna have 27 to the 2/3. And we're gonna have x to the, that's gonna simplify, 8.
6.
I think it's 8.
I think it's 8.
Oh,
Yeah,
wait,
I'm pretty sure it's
hold on a
8.
minute, hold on a minute. Yeah, I'll be safe.
Okay, now what's 8 to the 2/3 mean?
What is the
Cube root of 8 squared. So the cube root of 8 is 2, squared is 4. So I have 4, y to the 10/3. The cube root of 27 is 3, squared is 9. And there is my final answer. the answer you'll get no matter what order you do stuff. So if you have to do stuff in a different order, that's perfectly fine. Now, on this particular quiz, this was a bonus question. It's a required question on your quiz. So let's practice it. You guys are smarter than the group that took this quiz.
Divide by 9.
So one option is to divide by
9.
9. It's perfectly wonderful and allowed. So I have 1/3 2x, the 2x minus 4 equals 9 times 3 to the x.
Everything equals.
We notice that every number in the problem is a power of 3. So what's 1/3?
-1.
3 to the negative first. So this is 3 to the negative first to the 2x minus 4.
Yes.
This is 3 to the second and 3 to the x. Now, be careful. These right here, this is going to become 3 to the negative 2x plus 4. Would you agree with that?
Yeah.
And then over here, these are both 3, so I can put them together by doing what with the exponent?
3 to the 2x.
Adding them.
Oh, adding.
That's an add. That's an add. Remember, guys, if you have x cubed times x squared, if there's 2 x's, you add those exponents. If there's 1x but 2 powers, then you multiply the exponents. See the difference? So I have 2 x's. So therefore, I'm going to add those. So now I can do negative 2x plus 4 equals 2 plus x. I got 2/3, but I'm not sure about
No,
that.
that's all I got. You're good though.
Okay, so again, that's a required question where you have to solve an equation by getting a common base. Okay, I might find something different to put on as a bonus, I don't know. Okay, so again, at the end of the period, when you come up to get your phones, if you would like another copy of that practice to do at home, Dana, if you'd like another copy, you will certainly pick one up. It's just the same thing, but it's a fresh copy for you to practice if you wish. Okay? All right. Why are we all so tired? You should be so excited. You're almost here. All right.
Okay. Cut that out.
Here we go. We're ready for notes 3.6.
Yes, ma'am. You know I am.
Okay, my bad. Give up.
Hey, yo.
Okay. Now, stop. Nice. All right, so now we are going to do a bunch of word problems. And the word problems we do are going to use one of 2 formulas. All right, so we need to talk about these formulas and how we know which one to use when. All of the word problems on this page here, and there's what, 8 of them or so?
8?
All of them, oh no, there's more than that on the next page too, there's a whole bunch of them.
Oh.
Unless told otherwise, which you will see, on page 39 of the notes, there are the future value and present value formulas. You are not responsible for knowing these formulas, okay? They will be given to you. You get past that. I emailed them, but I don't know if they got it or not. You're not responsible for knowing the formulas. I will give you the formulas. You are responsible though for knowing how to use them. And some of them can get a little bit complicated. So let's talk about these. These you've seen before. You used these last year. Do they look familiar? Do you remember what they're for?
They're for investing.
This is called your compound interest formula. Compound interest.
Oh,
So your money in the bank, you're gonna compound it quarterly or compound it monthly or however they do it at your bank for your account. This is the formula. This is your continuous growth formula. Continuous growth. So this formula will be used for problems in nature, like bacteria growth or radioactive decay. It will also be used anytime your money, your interest is being compounded continuously. This is the continuous growth formula. This is compound growth, this is continuous growth. This formula is only used with money, only used with banking. This formula is used with money and with lots of other populations. Okay? Now, what do all these things mean? In both formulas, A is what we end with and P is what we start with. That's true of both formulas. Okay? That's the number 1. That's the number E. Those are not variables. That's a 1, that's an E. Euler's constant. R is the interest rate, or the growth rate, sometimes it's referred to as a growth rate, and it must be expressed as a decimal. So your problem will likely say something like 7%, but you will have to put that into the formula as 0.07. Always, both formulas. And there's 2 of them here, and they're the same thing. N is the number of times per year that we compound. So if we're compounding monthly, N would be 12. If we're doing it quarterly, N would be 4, and so on. And T is the number of years. Now, in this formula, T is time, but it does not have to be years. In this formula, T will be years. Remember, this is only used for money. Only used for your bank account, that's it. This one's used in all kinds of applications, so T can be minutes, hours, decades, anything. It's the time variable. Okay? So, as you read the problems, the first thing you have to do is decide which formula am I using. Okay?
Yeah.
So read problem number 1, we're on page 38. Read problem number 1. We're gonna use that one, and the key word is compound quarterly. Okay? So, how long will it take for 1,000? All right, so tell me, this is a formula, I need to plug some stuff in, what am I putting in?
1,000 is P.
1,000 is P, because that is what I am starting with.
1 plus 2.5, or
No,
0.025.
0.025 divided by 4 raised to the 4. If you put a 4 there, you're putting a 4 here.
That's right.
And how much time? I don't know. That's what I'm trying to figure out, right? How much time? When? What's A?
No, that's a good, that's,
2,000. Why is it
the
2,000?
double.
Because I'm doubling my money. That's right, I'm doubling my money. Alright, I'm gonna solve this equation. Here's a little fun fact for you. Anytime your variable is up here or up here, you're going to need logarithms. You're going to need logarithms to solve this equation because your variable is in the exponent. Whenever your variable's up there, you're gonna need logarithms, okay? So eventually I'm gonna need logarithms, but not step one. What's step one gonna be? Divide by 1,000. Absolutely, we gotta get rid of that. So 2 equals 1 plus 0.025 over 4 to the 4t. Okay. Now you need to get used to not rounding off, alright? This number, I think, does actually work out to be a finite decimal, but I want you to get past the need to do that. This is a number, would you agree with me? It's just a number. It's written weird, but that's okay, I got a calculator, I'm not worried about it. That's a number. I need to get this I need to find that exponent. So at this point, I'm gonna log both sides. Because what happens to the 4t now? It comes out in front. So I have log 2 equals 4t log this big ugly number, which I am not frightened of. I have a calculator.
What would you do if you, like back then, you didn't have one?
I didn't have one. Yeah, when I was your age, didn't we talk about this? We didn't have calculators.
No, but what were the steps you had to dig?
Boy, you do it all by hand.
Oh,
And
Just like,
haven't I shown you my book?
like, how do you?
So when you all bought a calculator, we had to buy what's called the CRC table.
Yeah.
Oh,
Right.
And this guy has, so when you press log 2 on your calculator, we had to look it up. This happens to be the trig functions. If there's a logarithm there somewhere on some page. Yeah, there they are. Sixth place logarithms, 6 decimal places. And all the arithmetic had to be done by hand. No calculators, so when you had to add and multiply and divide, and do it by hand. With 6 place decimals.
That's not even that bad, honestly.
Not that bad. We'll let you do it next time.
Yeah.
We'll let you do it next time.
yeah, I'm bad.
So, anyway.
Like, a little sounds easy.
Anyway, so I think, yeah, what you can't lose sight of is, I took this class about 50 years ago, doesn't that sound crazy? About 50 years ago I took this class, and the math hasn't changed. We did all the same problems you do. We didn't solve by graphing with intersections, because we didn't have that tool. We had to solve everything algebraically. And this, so when we needed the square root of 2, we looked up the square root of 2 in our table. All that stuff's in here.
Did you take geometry then?
Did I take geometry?
Like, how did that work?
What do you mean?
Stuff like, don't you have to graph a lot of geometry? No, you don't?
And approve a lot of geometry.
Oh, for
Okay. All right, so when you guys start whining and complaining, yeah, just remember, poor Mrs. Ford had to do it all by hand. Pages and pages of paper. Pages of paper. All right, that made me tough. All right, this is what I'm solving for. Ultimately, I want to know what t equals. That's what I want to know. So think about, I'm going to divide, all right? So maybe I'll divide by 4. So I'm going to have log 2 divided by 4 equal to t log this thing. Now, again, right? I'm not going to go to the calculator just yet. I want to get t by itself, so what do I need to do now?
Divide by log.
Divide divide by all of that, right? Oh, wait, this is not gonna be bad at all. Okay, here's what I want you to do. You're gonna take the log of 2 and divide it by 4. Just remember that when you do log 2, you gotta close those parentheses. Okay? And so that's the first division, because there were 2 things you needed to divide by. Now, you divided by log 1 plus 0.025 divided by 4. And did you get 27.812 years?
Yeah.
Yeah, of course you did. Yep. Yep.
So you don't really have to do all that.
You grabbed the original equation? Yeah, you don't. I mean, you don't need logarithms. I'm solving algebraically, you solve graphically.
And we have to solve algebraically on a wizard test.
Oh, I don't know, maybe 1, just to make sure you know the process. Okay, everybody okay? And the good news there is, we didn't, by not like typing in intermediate steps, we didn't end up with any round off error till the very end. Obviously, we had to round off the very end. All right, let's try number 2. Here we go. I'm gonna have to erase all this.
They do the semicolon.
All right, so number 2, you think we need the same formula. All right, so what are we gonna have? What's it gonna look like? What are
1,230.
is P
Yep.
R 0.03125
Yep.
0.0.
monthly,
Well, then you have this time now, 10 years.
12 times 10.
Yep. 120.
So I'm gonna go ahead and make that 120. I think that's a good idea. And this time we're solving for A. Okay, now wait a second. Am I gonna need logarithms here?
No, not plug in.
No, I'm just gonna plug it in. I'm gonna plug in exactly what I wrote. So 1230 parentheses, don't forget the parentheses. I got $1,680.53. Is that okay with everybody? That was just a type it in problem.
The next equation gives us the other one.
Yep, so for the next problem, we're going here because it isn't money, it's a population. And this is the formula you're gonna use when things aren't money. Alright, so tell me what to put in there. I have A, a P, an R, and a T.
Put P at 450.
P is 450.
We're solving for S. We're solving for T.
The R is 0.120.
Yep, 0.123. No, now that's already a decimal, so don't be changing that. We only change our percents. So this is 12.3%. It's already in a decimal form, so that's it.
And then 900, 900, yeah.
900 over here, because we're doubling.
Yes.
Okay, this one's gonna be faster without graphing, I think, because we're gonna divide by 450. And then, notice, we're solving for an exponent, so we're gonna need logarithms, but we'll use the ln, because there's an e in there. Because as soon as we do that, as soon as we put that ln, that's gone. So we have ln2 equal to 0.13t. And then we just divide. And that's gonna be your answer. So I think it's quicker to do that color than graph in this case. Did you get 5.635? And if the problem writer had put a clue in the problem, that would be like years or months or something, that's a time. But I don't have any idea if they can do a job. Is that all right with everybody? All right, what about number 4?
Using the first
Be careful.
No, second.
Be careful. Yeah. Read it very carefully. Do you see where it says compounded continuously? That's your continuous growth formula. It works for money if the interest is being compounded continuously. So we're using that. We're using the PERT formula. All right? So, what's the 35,000? A. That's the ending amount. What am I starting with? I don't know. Right? I don't know. My interest rate's 0.04.
Why are you doing 8?
Isn't it P?
Why am I doing 80? Oh, it should be P, yeah. The amount I start with, yeah, it should be P, yeah. Sorry, yes, P. That position right there, yeah, it's P. And T is 10. So I'm gonna go ahead and multiply those and just make that a plain 0.4.
That's
Am I gonna need logarithms? No. All I need to do is divide by e to the 0.4. Isn't that what I need to do to get p by itself? So 35,000 divided by second ln, that's how you get e, in case you forgot. 23,461.20. It's money, so I'll go to the nearest cent. Everybody okay with that? All right, what formula, that's your first decision, what formula for the next one?
Second one.
Yep, Kurt. Tell me what to plug in where. Joe, you okay today?
Yeah.
What's going on?
Just tired. Partying.
He's part of the thing.
Yeah.
I was studying, I was up late studying for forensics.
Studying at a party.
He was at a basketball game.
He went to the Pacers game last night.
Looking ended at 9:30.
Yeah, he stayed late because his alcohol is Pacers. Right.
It's not needed.
His uncle owns the Pacers.
Yeah, his uncle actually owns the base.
Wait, actually? Well, his uncle's father.
Yeah. And it's gonna get passed down to his uncle very soon.
And then he's gonna get passed down to Gertie.
Yeah.
Gertie's of his.
He's told us about it like a while. Yeah.
All right, number 5, here we go. Find the K constant of an element if its half-life is 10.2 years.
Garvey. Half-life 50.
Go to Garden and love the team.
I don't know. Okay, and R is what I'm actually looking for, right? Okay, so what's A?
Find the K constant. If you don't know.
Yes, we do.
Wait, find the K constant. Oh, 25.
Yes. How did we get 25? You picked 50, and the minute we start with 50 in a half-life problem, we're gonna end up with 25, because that's what half-life is, right? You end up with half of what you had. Now, some of you might be wondering, well, what if I picked 60? Well, it isn't gonna matter, because what's the first step to solving this? Divide. And when you divide, aren't you gonna get 0.5 or 1/2 right here? So had we started with 60, if this would have been 60, then this would have been 30, but when I divided by 60, I'm still going to get 1/2. So it doesn't matter how much you start with, You just gotta end up with half of whatever that was. So now we're here. What are we gonna do? We're gonna ln both sides. That's gonna cancel. And then we will divide. Right? So we have ln 0.5 divided by 10.2. Whoa, 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 whoa. What happened? Does that make sense?
Yeah, it's a decay.
It's decay. And decay is negative growth, right?
That is right.
So R, which is your growth constant, of course is going to be negative in a decay situation.
Absolutely.
All right, number 6. Which formula? First for number 6?
It's the second one. First.
So 391 equals 193 e to the 0.222t. Is that right? So we'll start by dividing by 193. That is not going to go in evenly, so just leave it. It's okay. Just leave it.
I don't like seeing it.
I know you don't like seeing it, but you're gonna lose points for round off, so let's not do it. Then we will ln. So we have ln this fraction equal to 0.222t. So then we'll just divide. So ln 391 divided by 193 divided by 0.222.
Wait, so do you get the answer first of the food and
Doesn't matter. Just make sure you close the parentheses before you hit divided by. 3.180. And again, if I don't know what the time is, could be days, could be years, minutes, hours, I don't know. It's some amount of time, that's a time. All right? Next, which formula?
First one.
First one. How much will I have in my account
Yep.
if I start with 555?
1 plus 12.
0.035 divided by 12 to the 144th power. Where'd that 144th come from? 12 times a year for 12 years. Am I gonna need logarithms?
No.
Nope, just type it in.
That's just a simple arithmetic.
Yeah. As long as we got our handy calculator, it's a simple little problem.
Those are wonders. We better have it.
Yep, you better.
Yeah.
You better know I'm not having.
You're in for a rude awakening.
And you're gonna be in a little sticky situation.
All right, $844.17.
Definitely be a year.
Everybody good
I
with
got
that?
Very sticky.
All right, number 8. What formula for problem number 8?
Third.
Compounded continuously. We want to end up with 1,000, starting with 890. Don't know the interest rate, but time is 3.
You ready with my arithmetic?
We're going to need logarithms, but it's going to be an easy one because it's an ln. So let's divide by 890. ln both sides. So ln this fraction equals 3r.
Yep.
So we're just gonna ln that fraction and divide by 3. Oops, divide by. If you get 0.0388, which is about 3.88%,
Oh,
it says
yeah.
what interest rate will be required. So I'll say about 3.88%.
Yeah.
Oh, the,
Okay? Alright, let's turn to the next page, because now we got the big fancy formulas.
Oh.
So, many things in your life involve making payments. Alright? Now, none of the problems we just did involve making payments. So, I want you to think about this for a minute. In these problems, I walked down to the bank, I handed them $890, and I came back to the bank when I had $1,000 in the account. I was not making payments. I made a one-time deposit and moved on. That's what happened in all these. When you buy a car, if you buy it on credit, you have to make payments on that car payments. When your parents bought their house, they probably had a mortgage. They made house payments. Unless they're Joe, whose uncle always pays
His dad is.
Um,
His dad always like.
When I started years ago saving for my retirement, I make monthly payments, or actually every 2 weeks, payments into my retirement account. When, you're gonna wish you knew this, when you make payments, whether you are building up for the future, like my retirement plan, or paying off a debt, like a car loan or a mortgage, you are going to use one of these formulas. These formulas are used when you are making payments of some kind. If you are saving for the future, like my retirement, you use the future value formula. If you are paying off a present loan that you have, like a car loan or a mortgage, you will use the present value formula. Okay? Now, how do they work? Let's look at the first problem. Carlos purchases a new pickup truck for $18,500. What are the monthly payments? Kids, this is real life. Alright? This is real life. What are the monthly payments for a 4-year loan with a down payment of $2,000 if the annual interest rate is 2.9%? Alright, so first of all, he's got to pay off a loan. So we're going to use present value. Okay? Now, R is the amount of the payment. So in both formulas, R is the payment. Okay? This is the present value of the loan. So what is Carlos's loan? Whoa, read. Guys, no.
18,000.
No.
4 years.
Oh, Carlos's loan is 2,000.
4 years.
And 16,500.
16,500 is the loan. Do you guys know what a down payment is?
Oh, yeah.
Okay, so the car costs $18,500. He has $2,000 down, so he has to borrow the rest. So he's borrowing $16,500. Okay? Now, things work differently in these formulas. I stands for the interest rate. But it's 2.9%, and he is making monthly payments,
Well,
so it's 0.029 divided by 12. The I value is the interest divided by the number of payments a year you're making. He's making monthly payments, so it's 0.029 divided by 12. And that's the same as the I down here. That I and that I are the same. Now, the N is the total number of payments Carlos is gonna make. So he's gonna make monthly payments for 4 years, so, and that's a negative, this is negative 48. Alright, so digest that for a moment, because in a minute, we're gonna put that in our calculator. Okay?
Is it 80,000 or 60,000?
16.5, because he made a $2,000 down payment. Okay? Alright, everybody okay with all those numbers? Alright, so let's go to the calculator. I strongly suggest that you start here. Okay? Now type it in with me. I'm gonna type in that numerator exactly the way it's written, just the numerator. I'm gonna type that in just the way it's written. So 1 minus parentheses, 1 plus 0.029 divided by 12, close parentheses, raised to the negative 48 equals. Tell me what you got. No one got anything?
Well, I'm still plugging it in.
Okay.
this is huge.
0.1094, that's exactly right, Aiden. Now, keep in mind, that's only the numerator, okay? So now we're gonna hit divided by parentheses, 0.029 divided by 12. Now what do we got? Yep, 45.269, very, very good. So right now on your calculator, you have this number. You are solving for R. So what are you gonna have to do to get R by
Divide
itself?
out 45.
Take 16.5 and divide it by that number?
Yeah.
So 16.5, on my calculator, I have to do divided by second answer. You guys with newer ones can just highlight it and bring it down. I have to do 16.5 divided by second answer, and how much is the payment amount?
$364.49.
$364.49, that's exactly right. Exactly right. All right, we'll stop there and finish this up next time.
No, but Mark did come
My guess is that we will finish this in our next class, and then we'll start reviewing. So we,
Just kidding.
this is on, so our test will probably be the week after.
But he did what he did.
You're praying. Well, you're gonna pick up one of these, I'll put it on Elijah's desk, and then one an extra copy to practice. All right, here's next time I see you. What's this one? Oh, all right, let me get my video turned on. Grace, you